Hey, so looking around at how people are solving day 3 and 4 of Advent of Code this year, I think I would like to share something about how sets work because I think they could be really, really helpful, especially for those couple of days, but maybe also going forward. So I came up with a quick demonstration here. All right, so you can see up here in at the top, we see how we can just create a set. So if we call, this is Python, obviously. So we create a new set and assign that new set to the variable a, and this is what the interpreter spits out when we just type a. So it gives us a set, empty set. So this is another way you can specify a set. It looks very much like a dictionary, but it differs by not having any keys, right? You only see the nonsense. They don't have any values, so it's kind of like a dictionary with only keys. And you can see here that they are, when they get printed, they still maintain the order. That's an implementation detail. There is no guarantee about the order in a set. They're just a pile of elements that don't have any order or anything like that. So this is just like an interesting little detail, but you cannot rely on the order here. Okay, so some of the basic operations that you have with a set is you start out. Let's just create a new set for this. Okay. And you can see we start by creating an empty set, and then we add foo, and then we get a set that has that single element in it. Pretty straightforward. If we do the same thing again, still only one element remains in our set because it's the same value. So any value that can be compared, so it has the underscore eq underscore method, or you can anything that is hashable and can be compared can go into a set, and the set mechanics automatically make sure that you only have one copy of the same thing in there. So you can add stuff and you can remove stuff. So we continue on to the same set that we call a. So we add bar and remove foo, and now we only have bar left. Okay, so let's see. These go down here. My bad. There we go. Okay. So now we try to create two different sets, one that has foo and bar, and one that has bar and baz. And then you can see when you subtract them, you take whatever's in A up here, foo and bar, and then you subtract whatever is in B, which is bar and baz. Baz is not there, so it just doesn't, you can't remove something that's not there. That's just, nothing happens. But bar gets removed and you end up with just a single element foo. And you can do the inverse as well, and then you get baz, right? There are also union operations. So a union between two sets is just the set of all the elements that are in either B, A or B or both. Yeah, that's the union. So we get bar, baz, and foo. And you can see that the order is, not what we expected, I guess, but the order doesn't matter. It's the, when you compare sets, the order doesn't matter. You can print it twice in a row. You're not guaranteed that they're going to be in the same order. They just, their order has no meaning. Then we have A dot intersection B, which gives us the intersection between the two sets A and B. In this case, it is bar because that's the only value that is in both of the sets. We also have something called symmetric difference, which is basically the opposite So you take, it shows anything that is only in one of the two sets. So this is Baz or Foo in this case up here. Finally, we have, well, there's more, but of the stuff that I want to cover here, we're getting to the end. So we have the is subset method as well. So here we create a new foobar set, and we ask if foobar Baz is, if we are a subset of that. So foobar is a subset of foobar Baz. Yes, it is. Vice versa, not true. Obviously, and two sets that are the same are considered subsets of each other. I don't think there's a strict subset function, so you would have to check if something is a subset and whether they are identical, and yeah, do that manually. Another cool way that you can create a new set is using a set comprehension. So you know how we have list comprehensions and dict comprehensions. This is a set comprehension. This is obviously stupidly simple. You just have foobar and Baz as oh yeah, you guys can't see my pointer. All right. So yeah, this just creates a set with these three elements in it. You can see here, foo, bar, Baz, and foo. Yeah. So the set function takes any iterable, which includes strings. So this gets turned into a set of all these individual characters. And this is a neat way to create a range, a set of the numbers from 5 to 9. And this right here, probably helpful on day 3 where we were doing the rucksacks. And this one down here is super helpful for day 4 where we're looking at sections that the elves are going to be cleaning up. And turning these into sets, you get the answer almost for free simply by performing these set operations. You're asking, is this something a subset, or is there any overlap, i.e. is there an intersection? And yeah, with these new maybe new things in your toolbox, maybe days 3 and 4 are easier, or at least you can maybe see a different approach to solving them. Yep, that's it. Sets in Python, yeah, they're pretty handy.